In these problems, we're working with something called a weighted average. Sometimes a teacher might organize their class so that they say, a midterm is worth 3 quizzes and the final exam is worth 5 quizzes. And so the quizzes would all be weighted 1, the midterm weighted 3, and the final exam weighted 5. How the teacher actually figures that out is like this. Let's look at this particular problem. It says Dorothy's test scores were 92, 85, 94, and 76. What was her weighted average if the tests were weighted 2, 1, 2, and 5 respectively? So it just means they're in the same order. So if the 2 came first, this would be weighted 2, and then 1, and then 2, and then 5. All right, before we calculate this, let's just think for a minute. She got a pretty high score in this one that was weighted 2, slightly lower in this one weighted 1, a really high score in this one weighted 2, and then the one that's weighted the most, that has the most impact on her grade, was pretty low, was a 76. So what we can expect is that her total average here is going to be skewed more towards the 76 than towards those higher scores. So that's what I should be looking for in the answer. I mean, these are going to make some difference, but this is going to make the most difference. Now, the way you calculate a weighted average is you multiply each of the tests by the weight. So 92 times 2, we're going to add all these together. 85 times 1, plus 94 times 2, plus 76 times 5. And then with an average, usually you add things together and then divide. We're going to divide by the number of weights. So 2 plus 1 is 3, plus 2 is 5, plus 5 is 10. So all of this gets divided by 10. So multiply this individual scores by the weight, divide by the total of the weights. So let's go ahead and calculate that. So our average here, our weighted average, is 83.7. Let's look back and think. So she got some 90s, she got an 85, and then she got a 76 that was worth a lot. It makes sense that this is skewed more towards the lower 80s than towards the 90s. So I think that's a sign we did something right there. Let's look at one other type of weighted average situation where you calculate this slightly differently. This one says, in the Olympics, the athlete received a 70% score on the compulsory exercises, which were weighted 75%. In the optional round, which is weighted 25%, the athlete received an 80%. It gets confusing with all the percents. Our answer, we want to be a percent. So the score was 70%, and we're going to multiply it by the weight. The weight of that was 75%, but when you multiply something, you multiply it as a decimal. So this is going to be times 0.75. Remember, you move the decimal point 2 places to convert a percent to a decimal. So that's the first one. She scored 70% with a weight of 0.75. We're going to add the next piece, where the athlete scored 80% and the weight was 25%, or 0.25. And then you add things together and then you divide them. You divide them by the total of the weights. In this case, the weights are 0.75 and 0.25. They add up to 1. So we really don't actually have to do the division part here. When you break the weights into percents, as long as it adds up to 100%, you're all good with the division. So we're just going to do the multiplication and the addition here. So 70 times 0.75, that's 52.5. And 80 times 0.25, and that's 20. Now before we finish the addition, let's think about this. Most of her score, 75% of her score, came from that 70% score. So it's going to be closer to 70 than 80, or it should be if we did this right. The 80 is only worth 25%. So 52.5 plus 20 is 72.5, and her score was in percent, so it's 72.5% that she scores. So that is a little bit of work with weighted average.